Hello and good afternoon kids. Welcome once again to this short tutorial video for class 8 students. And since we have in the last video we have finished with the topic cubes and cube roots, so the next topic for today's lesson will be fundamental concepts and operations. So in this topic, this topic will comes under algebraic portion. So since we have done few chapters on the arithmetic part, so let's begin with algebraic as well. Okay, so for fundamental concepts and operations, so first of all we'll be dealing with the terms constants and variables. So constants, what does the term constants means? The terms having the fixed values. Constant terms are terms having fixed values. For example, 1, 2, 3. Or in general words, or in simple words, you can say the numbers. If you see a number, then it's a constant term. You can directly predict that, isn't it? A fraction, it may be a fractional form, a integer, negative integer, and so on. Is it okay? A simple, a constant term means nothing but simple a number. Okay. And the second one we have here, the second term we have here is variable. So variable means which does not have a fixed value. That means it does not have, we don't know the exact value for a variable, but it doesn't mean that it does not have a value. Remember, in every equation a variable has a value which we does not know. And algebraic expressions, the sums under algebra everything will be simply finding the value of the variables. So variables basically they are denoted with alphabets. See, X, Y, Z, A, B, C, and you can use any other alphabets as well. Okay, so variables which does not have a fixed value. So, and in simple words we can say that whenever in an expression an alphabet is used, remember the alphabets are your variables. Is it okay? So the next topic, an algebraic expression. Yeah, what does an algebraic expression means? So an algebraic expression is a combination of a constant and variables. See, an algebraic expression is a combination of constant and variables connected by the signs plus, minus, multiply or divide. A simple combination of constant and variables connected with the signs plus, minus, into or divide is known as your algebraic expressions. For example, simple C, you might have seen this kind of algebraic expressions as well, isn't it, in your previous exercises as well. 2x plus 3, simple. We have got constant terms 2, 3 in here. We got variables also x in here connected together with a plus sign. So it's a simple algebraic expression. Similarly, x square plus y plus 3. See, we got variables, constant terms in here connected together with a positive sign. So it's a simple algebraic expression. Is it okay? Okay, so moving on to the next topic we have here, types of polynomials. Yes. Now types of polynomials. So monomial. First comes monomial. Monomial means simple, just one term. One term, just simple one term is known as monomial. The term, see, the term itself tells you that. Mono means one. So one term. Example, so simple, see, 2x, 3xy. So no matter how many variables are there, it doesn't matter. So, and it doesn't matter whether it's a positive integer or negative integer as well. See, I have got another variable as minus 4x square y. So simple, a single term is a monomial. That's it. Okay. So similarly, binomial, two terms, example. And remember, terms can be separated only with a positive or a negative sign. Remember that. Terms can only be separated with a positive and a negative sign. Similarly, in the second case, we have here 2x plus y. Now see, it's because of this plus, we have got two terms in here. 2x plus y. 2x, one term, y, second term. So first and second term, two terms combined together with a plus sign. So overall, it has got two terms we can say. So therefore, it's a binomial. So similarly, this one in here, see, 3x square plus x. And this one in here, 2x plus 2y. Is it okay? And similarly, trinomial as well. Trinomial, tri means 3. So 3 terms, example, again the same thing. Terms can only be separated with a plus and a negative sign, as I have already said. So x plus 2x square plus 3y, 3 terms. 3 terms are there connected with a positive sign. So it's a trinomial. Second one we have 2x plus 2y minus 2z. So we got 3 terms connected with a plus and a negative sign. Again 3 terms. So it's a trinomial. Is it okay? So these are the basic things, and this The basic of algebra you have done in class 7 as well, I hope, isn't it? And an algebraic expression, yeah, an algebraic expression containing more than 3 terms. Remember, an algebraic expression containing more than 3 terms is called a polynomial. Simple. Polynomial, but everything, these two, that is monomial, binomial, trinomial, they also comes under polynomial. The topic is same, that is the polynomial. It's only that we have got names for the 3 terms. That is, for 1 term it can be called as monomial as well. For 2 terms it can be called binomial. For 3 terms it can be called trinomial as well. And again, if it goes for more than 4 terms, 4 or more than 4 terms, it can again be called as polynomial. These are also known as polynomials, remember. It's just that for 1 term we have got specific name that it can be also be called as monomial. 2 terms binomial, 3 terms trinomial. Is it okay? And yes, now this one is important. See, degree of a polynomial. Now these are important things. So if the polynomial is in one variable, then the highest power of the variable is called the degree of the polynomial. See, polynomial with one variable. So what do we have here in example? As I have shown you in the example, I have got written 9x minus 19. So we know that what do we know is we got 2 terms in here. It's a binomial, isn't it? It's a binomial with one variable. See, variable, we have got one variable x. And what is the degree of the x? See, remember your lesson from the exponent part. The degree, the power. What is the power of the x? If nothing is written out there, it means it's 1, isn't it? So the power, highest power of the variable, that's what we have written. See, so highest power of the variable, we have got this one variable. The highest power is 1, so its degree is simple 1. That's it, finished. Okay. Similarly, for the next one we have here 4x plus 3x square plus 2. What do I have here now is I got trinomial. So for trinomial, what do I got is I got variable. See, got variable x, I got variable x square as well. Now see, in terms of x and x square, what do I see is this variable has a greater power, isn't it? That is, the power is 2 as compared to this variable. It has got 1, it has got 2. So the highest power is known as, highest power of the variable is called the degree. So therefore its degree is 2. Is it okay? Now for the third one, what do I have here is again I got a trinomial. I got a trinomial with variable in terms of y. So y with the highest power for this variable as 4, so its degree is 4. Is it okay? And yeah, one more thing, that is the relation. Remember, the relation between a constant and a variable. Whenever a constant and a variable term is written together, when a constant and variables are written together, the relation between them is always multiplication. Like for example, 2x, it can be written as 2 into x. So even though it's just written as 2x, remember the relation between them is into, and it can also be written as 2x. So why to bother in writing multiply and all, isn't it? So it can simply be written as 2x. Is it okay? Similarly for 3xy, it can also be written as 3 into x into y. So it's simply we write simplification as simply we write 3xy. Is it okay? And one more important thing, yeah, this one, that is whenever a constant and a variable is written together, what we just learned is the relation between them is multiplication, isn't it? The variable, here we have x as the variable and 2 as the constant term. Whenever these two terms are written together, remember at that time the constant term is also known as the coefficient of the variable. In the first case we have the variable as x, so it is known as coefficient of x. See, the constant term is known as coefficient of x. Is it understood? The second one I have written 3xy. So I have got two variables in here. The constant term is 3. As I said, the constant term is also known as the coefficient of the variable. So for the second case, I can say that 3 is the coefficient of xy. Is it understood? The constant term with the variable, which stays with the variable in the relation multiplication. Remember, in the relation multiplication is also known as the coefficient of that variable. Is it okay? Okay, so moving on to the next part, we have, okay, now again we are dealing with the degrees of the polynomial. So again, now the second case we have is, we can have, in the second type what we can have is, we can have more than 2 variables as well, isn't it? 2 or more than 2 variables. So what happens there is, if a polynomial has 2 or more variables in them, then the sum of the powers of the variables in each term is found, and the highest sum so obtained is called the degree of that polynomial. So I'll explain it. Remember, listen carefully again. So whenever we have 2 or more than 2 variables, what are we supposed to do is we are supposed to, first of all, we are supposed to add the powers. So whichever the power is the highest, that will be the degree of that polynomial. Is it okay? So here from the first case what we have is we got 3x square minus 5x square z square plus x cube plus 2z cube. See, I have got one variable out here, two variables together in here, isn't it? The relation is multiplication. There is a single term, remember that, isn't it? Because the relation is multiplication. And I get again plus x to the power 3 plus 2z cube. So here what do I see here is this power is 2, this power is 3, this power is 3. But what do I see here is I've got two variables together as well. So what I am supposed to do, I need to add the powers, isn't it? So as soon as I added up the power, what do I see is 2 plus 2 is 4, isn't it? For second term, the power is 4. That is the sum of the powers is 4 for two variables, isn't it? So therefore, the degree of the polynomial is 4, the highest power, the sum. Is it okay? Okay, let's do one more time. For number 2, I have picked for number 2 18x square y minus 7y to the power 4 plus 2x cube y to the power 4 minus 3x to the power 4 plus 11. So what do I see here is the first term and the third term having two variables together. See? So when you add them up, let's see what happens when you add. So 2 plus 1, we have 3 as the first power. For the second term, we got 4 as the power. For the third term, I have 3 plus 4, that is 7. 7 as the power, isn't the sum of the powers. For the fourth term, I have 4 as the power. For the fifth term, what will be the power? It will be 0. Remember, it will be 0 because it can also be written as 11x to the power 0. Remember, anything to the power 0 is 1. X to the power 0, it can also be written as x to the power 0. X to the power 0 is 1. The relation between variable and a constant is multiplication. So 11 into 1, it's 11. So, and here we have this term, that is the third term with the highest power, that is 3 and 4, 7. So the degree of the polynomial is 7 out here. Is it okay? And the degree of the constant term, as I have said for 11, see, degree of the constant polynomials like 7 and 23 is 0, as they can be written as 7x to the power 0, comma 23x to the power 0. Relation between constant and variable is multiplication, we know that, and we know from the exponential part that the exponential topic that anything to the power 0 is 1, so x to the power 0 is 1, so 7 into 1, it's 7. See, the value hasn't changed. Okay, now the second part we have here is linear polynomial. So, linear polynomial. What is a linear polynomial? Linear polynomial is nothing but just simply a polynomial with degree 1 is known as your linear polynomial. Polynomial in which the highest, the degree, if the degree of entire polynomial is just 1, it's known as a linear polynomial. Similarly, for quadratic polynomial, if the degree is 2, it's known as quadratic polynomial. The linear, the degree of the entire polynomial, if it's 2, then it's known as quadratic polynomial. And the third one we have here is cubic polynomial. So the degree is 3. So the degree 3. So the degree is 3 in here. Cubic polynomial with degree 3. The highest order is, if in a polynomial we have got the highest power, that is the degree of the polynomial is 3, then it's known as cubic polynomial. So after that, now this one is very important. Remember, now this is the most important of all, like terms. An algebraic expression having the same variables are known as like terms. Otherwise, they are known as unlike terms. Remember, an algebraic expressions having the same variables. Remember, the variables has to be same as well as the powers of the variables also has to be same. Remember, it cannot be like the powers, they have got the variables, you have same variables, everything is same and the powers are different. They will be unlike terms. Remember, for like terms and unlike terms, how can you differentiate between them? The variables has to be same as well as the powers of the particular variable also has to be same. Like for example, in like terms I have written, say 2x comma and 3x. Whenever you are comparing these two terms, single monomial terms, what do I see here is the variables. If you go with the variables, I have seen x and x. So now the power also 1 and 1. So we can simply call it as like terms. So the variable, the coefficients doesn't matter. Remember, the coefficients doesn't matter, as well as the sign of the coefficient doesn't matter. It's just that the variable has to be same as well as the powers of the variable. Similarly, the second term we have here, I have given minus 2xy minus and minus 4 divided by 3yx. So look at here. What do we have here is x and y, the variables. I have got y and x in variable. Again, I'm telling you that these are like terms. Why? It's because, see, it's just written in, the y is written in front and the x is written at the back. So we know that the multiplication is associative. The relation is multiplication, isn't it? The order doesn't matter in multiplication, isn't it? Whether you write y at first or y at second, it doesn't matter. Unless and until the power and the variable has to be same. So see, what do I see here for y? The power is 1. Similarly, in this case, the y is 1. The power is 1. For x also the power is 1. For this x also the power is 1. So these two are like terms. Is it okay? The constant doesn't matter for like terms. Remember that, for like and unlike terms. And similarly for this one, I have just given the variable c minus x square y comma x square y. So even though I haven't written the coefficients, that is the constant terms, just by looking at the variables I can tell that these two are like terms, isn't it? And what is it? What will be the coefficient if the coefficients are not given? If the coefficients are not given, the coefficient will be 1, because the relation between them is multiplication, isn't it? And 1 doesn't change the value, so the coefficient will be 1. Is it okay? So, and for the last topic for today is unlike terms. Yeah, for unlike terms, what do we have in unlike terms is that, again, see, for unlike terms, as I said, even though for two terms the coefficients are same, see, coefficients are same, what do I see here? And the variables are also same, see, xy, xy, the variables are also same. In just general, the variables are also same. But what do I see in the second term is that the power of y is 2. But for the first term, the power of y is 1. So that makes it unlike terms. See, everything is same, isn't it? Just looking at, just when you go, just look at once, you may notice that you may feel like they are like terms. See, the coefficients are same, the variables are same, xy, xy, isn't it? But still they are unlike terms. Why? Because of the power of y. Remember that. And similarly for this one as well, see, what do I see here is, and here what do I find out was the degree was same. See, what we learned about the degree for monomial with two variables, what we learned about degree. For two, when we are dealing with two variables, we need to add them up, isn't it? So the powers, so 2 plus 1, the degree of this first term is 3. Similarly, the degree of this second term is also 3. So see, even though the degrees are same, I'm telling you that these two are unlike terms. Why? It's simply because of the power of the particular variables. Remember, so this x has power 2, this x has power 1. So that makes them unlike terms. For y, the power is 1. For y, the power is 2. See, is it okay? So this one, minus 3 by 2 xy square z minus 4 xyz. See, though the variables are same, still they are unlike terms. Why? Because of simply this y. First term with the power of y as 2, and second term with the power of y as 1. Is it okay? So I hope you have understood today's lesson. So today we'll be just dealing up to here the simple terms related to the algebraic expressions. So what I want you to do is just note down a few important topics from here. So the exercise we'll be doing on the next video. So I hope you kids are safe at home. So stay tuned, stay safe. So that's all for today. Good day.